Okay, question 1. Given that y equals x squared minus 4x plus 3, find the gradient function dy dx. Show that the curve has one turning point and find the coordinates of this turning point, and then state whether the turning point is a maximum or a minimum. Okay, so dy dx, the derivative function, equals 2x minus 4. Now for stationary points, the derivative function dy dx always equals 0. And the reason that dy dx equals 0 for stationary points, if we just consider any curve, this is a quadratic, so the quadratic is going to be shaping up. Now, regardless of what it looks like, at the turning point, regardless of what the function looks like, at the turning point of a curve, if we draw a tangent at the turning point, it is a horizontal line, and the gradient of a horizontal line is always 0. Now, because gradient is the change in y over change in x, and in calculus we indicate this as dy dx, since the gradient of a horizontal line is always 0, when it comes to a curve, the derivative function dy dx always equals 0 at stationary points, because of the fact that when we draw a tangent to the curve at the stationary point, that tangent rather, has a gradient of 0. So that's the reason why dy dx equals 0 at stationary points of curves. So dy dx is 2x minus 4, so 2x minus 4 equals 0. 2x equals 4, x equals 2. The fact that there's only one, this is a linear equation, 2x minus 4 equals 0. The fact that there's only obviously one value of x, that means there's only one stationary point, right? So x equals 2, so the x coordinate of the turning point, the stationary point, is 2. To find the y coordinate, we substitute x equals 2 into the function. Just going to call the function f of x. It's just a lot easier to work with. So f of 2 equals 2 squared minus 4 times 2 plus 3. That's going to be 4 minus 8 minus 4 plus 3 is minus 1. So the stationary turning point is 2 minus 1. And then to state whether it's a max or a minimum point, well, this is a quadratic function, and we clearly know that it's shaping up. So we know just from the nature of the quadratic function that this is going to be a minimum stationary point. Now, to find the nature of stationary points, turning points, we use the second derivative function. So we can also use the second derivative. The second derivative is just the derivative of the first derivative. The second derivative is indicated as follows, and really is written as the derivative with respect to x of dy dx. So that's what this notation is. This is not squared, by the way, so that's not how we speak when we talk about the second derivative function. We're just going to say second derivative. So it's d dx, dy dx. That's the second derivative. So the second derivative will be 2, right? Because the exponent of x is 1 times 2, and then 1, there'll be 2x to the 1 minus 1 is x to the 0, which is just 1, and 2 times 1 is 2. Now, if the second derivative is positive, greater than 0, we always get a minimum stationary point. And if the second derivative is negative, less than 0, we get a maximum stationary point. So even if you haven't done the second derivative function yet, it's very, very easy. You just derive the first derivative. If the second derivative is positive, we have a minimum stationary point at that particular x value, at that particular x coordinate of that stationary point. And if the second derivative is less than 0, we get a maximum stationary point. It's as simple as that. So the fact that the second derivative of this quadratic function, y equals x squared minus 4x plus 3, is 2. 2 is obviously greater than 0. If the second derivative is greater than 0, we get a minimum stationary point, and that just confirms what we already wrote down previously, because we know what the nature of the quadratic function is. Question 2. Find the turning point of the curve y equals x squared plus 6x minus 3, and then state whether it's a maximum or a minimum turning point. Okay, so we're just going to call this function f of x. It's just a lot easier to work with. Now, if the function is y equals x squared plus 6x minus 3, the derivative function is dy dx. The function is f of x, and y equals f of x, which is why it's interchangeable in this notation. If f of x equals x squared plus 6x minus 3, then the derivative function is f prime x. So for stationary points, the first derivative function, the gradient function equals 0, so f prime x equals 0. The derivative of x squared plus 6x minus 3 equals 2x plus 6. So 2x plus 6 equals 0. 2x equals minus 6. X is minus 3. Minus 3 is, x equals minus 3 is the x coordinate of this turning point, or the stationary point of this curve, of this function. So to find the y coordinate of the stationary point, we substitute x equals minus 3 into f of x. So f of minus 3 equals minus 3 squared plus 6 times minus 3 minus 3. That's 9 minus 18 minus 3. 9 minus 8 is minus 9, minus 9 minus 3 is minus 12. So minus 3 minus 12 is your stationary point. To determine if it's a max or a min, again, this is a function that's going to shape up, and we know that because the coefficient of the x squared term is 1, which is obviously positive, and therefore if the coefficient of x squared is positive, the quadratic function will shape up, which means we're going to have a minimum stationary point. We can use the second derivative function again to verify this. So the second derivative, f double prime x, will be 2. Now since 2 is greater than 0, this implies that we have a minimum stationary point. Okay, the function y equals 1 plus 5x minus x squared again. Okay, well, let's just leave it in this form because they're using this notation dy dx. Just write this in standard quadratic form. Minus y equals minus x squared plus 5x plus 1. It doesn't make a difference. It's just a nice convention, nice notation to have it in descending powers of x. So dy dx equals minus 2x plus 5. Find the turning point of the curve. So for stationary points, turning points, dy dx equals 0. So minus 2x plus 5 equals 0. 2x equals 5. X is therefore 5 over 2. 5 over 2 is the x coordinate of the turning point or stationary point of the quadratic function of the curve. So again, interchangeable, y equals f of x. So f of 5 over 2 equals 1 plus 5 times 5 over 2 minus 5 over 2 squared. Which is 26 over 4. So the stationary point is 5 over 2, 26 over 4. And because the function, the coefficient of x squared is negative 1, which is obviously less than 0, this function is going to shape down. The quadratic function shapes down when the coefficient of x squared is negative. So we are going to have a maximum stationary or turning point. We can use the second derivative just to confirm this. So the second derivative equals minus 2. Minus 2 is clearly less than 0. And when the second derivative is less than 0, we have a maximum stationary point.